Welcome to the practical part of this mini course where we are implementing CQRS with MongoDB inside of the modular monolith architecture. This is what we are going to cover inside of this lesson. We will start by setting up MongoDB using Docker inside of our existing Docker Compose setup. Then we're going to configure MongoDB with OpenTelemetry, and we're also going to add MongoDB health checks, and then we are going to use MongoDB on the read side of our CQRS setup. We are going to process a set of projections and produce an optimized read model that we can easily query and return from our application. We are going to start by introducing a new service inside of our Docker Compose YAML file. I'm going to add a code snippet at the bottom right after we configured Jaeger, and this is going to introduce a new container into the Docker Compose setup, which is going to be our MongoDB database. I gave this service a name of Evently Mongo, following the existing naming convention that we already have, and we are going to run the latest version of the MongoDB image. I gave this container a name of Evently Mongo, and then I'm setting up some environment variables, which are going to be the username and password of the root user inside of the MongoDB database. I'm also configuring a respective volume that will be persisting the data for this container. And then I'm exposing MongoDB locally on the port 27017, which is also the default internal port inside of the Mongo Docker container. The next thing we want to do is to introduce a respective connection string that's going to allow us to connect to the MongoDB database. So let me introduce a connection string in the connection strings section, and let's give it a name of Mongo. I'm going to leave an empty value in the default application settings file, and then I'm going to add the correct value inside of our app settings development JSON. And let me add the Mongo connection string, and then the value of our connection string is going to be this. So we are using the MongoDB protocol to connect to the respective database, and then I'm specifying the username and password of the root user that we are using to connect to the MongoDB instance. I'm also specifying what is the URI that is going to point to my database instance, and this is Evently Mongo. And then we're specifying the respective port where MongoDB is running. And you can notice that we configured all of these values inside of our Docker Compose setup. So here is our service name, which is also the internal host, and this is the internal port that we are connecting to and the respective username and password. With this initial setup in place, let's just start the application and see if we can get the MongoDB container up and running. You can see that our application is running in the background, and if I open up Docker Desktop, we will be able to see the MongoDB container, which is running as part of our Docker Compose setup. We can go into the container and observe any of the container logs, and we should also be able to connect to this container instance from MongoDB Compass. If I navigate to MongoDB Compass, which is the graphical user interface for MongoDB, I can try to connect to the MongoDB instance that's running in a local Docker container. All I need to do is specify the username and password of the respective MongoDB instance in the connection string, and I need to specify localhost for the URI, and of course you can just provide the respective connection string value that we already added inside of Visual Studio. So let's go ahead and click connect, and we should be greeted with a screen like this where we can check out some default databases that are created inside of MongoDB. Now let's go ahead and create a new database. I'm going to call it attendance, and I'm giving it this name because we will be using it from the attendance module. Let's also create a collection called event statistics, and let's click create database. And this is going to create a default database instance and the respective collection inside, which is like a table inside of our relational database. From here, you can go ahead and import your data using a JSON or CSV file. You can even insert a document manually, but we won't be doing any of this. Instead, we're going to jump into our application and start using MongoDB. Let's introduce the respective connection string inside of our program file. So I'm going to reuse the connection string that I have for Redis, and let's call this the Mongo connection string. We also have to use the respective connection string name when calling the getConnectionString or throw method. Then I'm going to pass this connection string as an argument to the addInfrastructure method, and of course we are going to expand this method to also include this argument. So let's go into this method and let's add another parameter that we will call the Mongo connection string. Now we need to install a few NuGet packages into the common infrastructure project. So let's go ahead and look for MongoDB, and I'm going to install the MongoDB driver let's go ahead and add the latest version. I'm also going to install ASP.NET Core, Health Checks, MongoDB. Let's go ahead and install the latest version. And then let's look for the Open Telemetry package, which is MongoDB Driver Core Extensions Diagnostic Sources. Let's also install the latest version of this NuGet package. Now I can close this down and go back to my infrastructure configuration. And let's first see how we can configure MongoDB with OpenTelemetry. We need to introduce an additional source for our application traces, and I'm going to say add source and then specify MongoDB driver core extensions diagnostic sources. And this is just going to be the namespace of the respective NuGet package that we just installed. Next, we need to configure some services with dependency injection for working with MongoDB. And we're going to start from the Mongo client settings class. And I can call one of the two static methods available to create a new Mongo client settings instance, and I will choose from connection string. Now I can pass in my Mongo connection string and create a variable that's going to hold the Mongo client settings. Then I need to configure this instance of Mongo client settings to further set up application traces. So I'm going to provide a delegate for the cluster configurator property, and I need to call the subscribe method on the cluster builder. And then we can pass in a new instance of an iEvent, and I'm going to pass in a diagnostic activity event subscriber. Here I'm going to pass in a new instance of instrumentation options, and on this class I want to set the capture command text property to true so that we can see the commands that MongoDB is sending in the distributed traces. And then let's register a new service. I'm going to say add singleton, and this is going to be a singleton instance of the iMongo client service. I'm going to provide a value of a new Mongo client as the implementation of this service, and we need to provide either a connection string or a Mongo client settings instance. And of course, I'm going to pass in the Mongo client settings instance, which is also going to contain the connection to our MongoDB database instance. And then this next part is optional, but it's helpful if you want to use C# GUIDs inside of MongoDB. So I'm going to paste in a code snippet, and then we're going to examine what we have here. I'm configuring some static settings, and I'm setting the GUID representation to be GUID representation standard, and then the GUID representation mode to version free. This is going to allow us to persist C# GUIDs into MongoDB and also be able to view them in a human readable way. Then I'm going to register a serializer and specify a GUID serializer instance and provide the GUID representation standard value. The reason I have these pragma comments is because for some reason these values are flagged as deprecated, even though they are still in use inside of the MongoDB driver. So this is just a way from stopping our code analysis from yelling at us, and I disabled this static analysis for these two properties. Let's also introduce the health check for MongoDB from our program file. So I'm going to say add MongoDB, and I can pass in the MongoDB connection string. And then let's close this down because it takes care of our initial setup. And I will move over to the attendance module inside of the modules folder because this is where we will be using MongoDB. And I want to focus on the event statistics folder. Here we have a use case or a query for returning an event statistics response. If we take a look at the query handler, you will see that this is returning data from the respective table in our Postgres database. Now, what's interesting is that this is a materialized view. And we talked about this use case in the materialized views lesson in the core course, but let me give you a brief overview. Inside of our domain, I have an event statistics class that contains some useful information about an event. These properties here come from the event table, and then we have a few integer values for how many tickets were sold for a particular event, how many attendees have checked in, and a list containing the duplicate check-in tickets and another list for the invalid check-in tickets. So this represents a materialized view that we are currently storing inside of the Postgres database, and I want to update this entire workflow to use MongoDB. You will see that this is going to allow us to easily introduce some additional features, but let's go step by step. I'm going to take the event statistics class and take it out of the domain project, and let's move it under the event statistics folder in our application layer. Next, I'm going to get rid of the private setters because I want to make this into a mutable type, and this is something that's recommended when working with document databases because it's quite cumbersome to work with immutable types, as document databases want to serialize the public properties on a particular type. So this will make it easier for us to work with the event statistics type. I'm also going to assign a default empty list to the two list properties that we have. And then the next thing I want to do is to introduce an interface inside of this folder that's going to represent a repository that I will use to interact with MongoDB. So let's call this the event statistics repository, and I'm going to define 3 methods on this repository. So the first one is going to be a task, so it's going to be an asynchronous method returning an event statistics instance, and let's call this getAsync. It's going to accept an event ID as the argument, and we can give it an optional cancellation token. Then let's add one more method. It's also going to be asynchronous, and this one will be insertAsync. It's going to accept an event statistics as the argument, and we can also pass in an optional cancellation token. And then the last one is going to be an interesting one because it's going to be specific to MongoDB, and I'm going to call it replaceAsync. And this is the underlying method that I will be calling on our document database, but I'm going to explain what it's doing when we go ahead and implement this. So with our repository interface in place, let's go ahead and update all of the implementations under the event statistics folder to start using MongoDB as the backing store. So that means that I will slowly get rid of anything that's referencing our SQL database, where we can at least. Let's inject the iEvent statistics repository into this query. And a good first step would probably be to just update this query to directly return the event statistics class. This is going to be our materialized view, and we can save on some time if we don't have to map this to a response object. I'm doing this mainly out of practicality, but you can still continue using a response object if you want to. So I'm going to update this to return an event statistics file, and then let's update our query implementation to return the same type. Because our folder and the class have the same name, we have to specify the full namespace. I'm actually going to adjust the namespaces in this folder, and this should fix the namespaces in my 2 files. And now let's go ahead and clean up this query. So I'm going to get rid of the constant for our SQL statement as well as our database connection, and I'm going to update the event statistics response with just the event statistics type. Let's make it non-nullable, and then I'm going to say event statistics repository get async, and I can pass in the event ID from the request.